Hello and welcome to this short demo video on data protection with SnapCenter for SAP HANA on Azure NetApp Files. We put together a series of demo videos where we explain how SnapCenter can be used to optimize data protection operations of your SAP HANA landscape. This video is part 2 of the series and we will focus on the different backup operations of SnapCenter. In this demo, we will use the HANA System Peer 1 in our lab setup to showcase the different backup operations of SnapCenter. We will trigger a snapshot backup operation of the HANA database and we'll see the different steps which are executed as well as the entries in the SAP HANA backup catalog and the snapshots created on the ANF volume. We will then execute a file-based backup and we'll check the HANA backup catalog entries and the backup files created on the backup file system. In the next section, we will demonstrate how a snapshot backup is created for non-database volumes, like the HANA shared volume. And finally, we will show the backup operations for a HANA system with enabled system replication. In SnapCenter, the resource view lists all HANA systems configured in SnapCenter. For this demo, we will use the HANA System Peer 1 and the system NB1, which is configured with HANA System Replication. To view the available backups, we select the HANA System Peer 1. The topology view shows all backups, which have been created for the HANA data volume. For our system Peer 1, we have configured schedules for snapshot as well as for file-based backups. For file-based backups, only the most recent backup is shown, including an icon which shows if the backup has been successful or not. In our example, the list of snapshot backups shows 6 backups and a single file-based backup. In HANA Studio, we can see the same snapshot and file-based backups. The backup names are the same as shown in SnapCenter. Catalog entries for system and tenant database are identical. Now we will create an on-demand snapshot backup of the HANA database by clicking on Backup Now. On-demand backups in SnapCenter can either be based on an existing policy or one-time, where the retention is configured specifically for this backup. We are using policy-based and click Yes. The backup operation is now started and we can check the status by clicking on the job listed at the bottom of the screen. The backup operation consists of 6 main steps. As a first step, an auto-discovery operation is executed to check if any relevant configuration changes on the HANA database have been done. Adding or removing a tenant would be an example which requires SnapCenter to adopt the list of tenants that are part of the backup. In a second step, auto-discovery of storage resources is executed to ensure that the ANF volume assigned to the resource is still valid. Then a HANA backup save point is triggered, which ensures that the HANA data volume persistence has a consistent state. Then a snapshot operation is executed on the ANF volume, where the HANA data volume is stored. Now the HANA backup save point is removed again and the snapshot backup is registered in the HANA backup catalog. And finally, retention management is done for data backups, log backups, and the HANA backup catalog. The backup operation took around 1.5 minutes. Keep in mind that the runtime will be in the same range even for very large databases with a dataset of 10 terabyte or more. Now we want to check the correlation of the backup in SnapCenter with the HANA backup catalog and the snapshot on the ANF volume. First, we check the HANA backup catalog in HANA Studio. We can see the new backup listed in the backup catalog of the system and the tenant database. On the ANF volume, which is used as a data volume for our HANA System Peer 1, we can also see the 6 old snapshots and the new snapshot that we have created before. The name is based on a naming convention defined in our backup policy and is identical to the name in SnapCenter and in the HANA backup catalog. SnapCenter also supports the execution of file-based backups. File-based backups can be used to run a block integrity check of the HANA database. The backup is started in the same way as before by selecting the HANA system and on-demand backup. We select our policy for the weekly block integrity check, which executes the file-based backup. The backup is started, and we can also see the different operation steps in the job monitoring view. The backup itself is written to the file system, which is configured in HANA as the target for file-based backups. You can see that the backup name is also using the naming convention defined in the backup policy. The file-based backups are also listed in the HANA backup catalog. In HANA Studio, we still see the old file-based backup, and I want to use this scenario to explain the retention management of SnapCenter. For file-based backups, we have defined a retention to only keep a single file-based backup. That means that with each creation of a new backup, the old backup gets deleted. When we refresh the backup catalog view in Studio, we can see the new file-based backup at the top, and we also see the old file-based backup got deleted by SnapCenter from the catalog based on the retention definition. Since the old file-based backup has been the oldest data backup in the list, also log backups up to the next snapshot backup got deleted by SnapCenter, since they are not required for any data backup recovery anymore. SnapCenter can also be used to protect volumes with unstructured data outside of the HANA database. Examples are the HANA shared volume or any application server data. An on-demand backup is triggered in the same way as for the HANA database. Since non-data volumes do not require any application consistency, the backup workflow mainly consists of the snapshot backup operation and the retention management. The snapshots are available at the ANF volume and follow the naming convention as discussed before. As discussed in our first demo video, HANA system replication hosts are configured in a resource group, which allows to manage backup operations for both hosts as a single entity. HSR-specific operations have been implemented in SnapCenter to always ensure that backup operations are executed at the current primary host, and to apply retention management across both HSR hosts. The backups of HSR systems are shown for the individual HSR hosts, just like any other HANA system. In our lab setup, all current backups have been taken at the primary host, since there was no failover during the retention period of 12 backups. The job log of a backup operation of our HSR system NB1 shows that as a first step, SnapCenter detects which host is currently the primary host. The backup operation is then executed on this host. With that, thanks a lot for watching the video, take care and bye bye.